example. So today we're going to sketch parabola by completing the square. So what's completing the square? So parabola of this form have a perfect square in it. Okay. All right. So the first step is to determine its turning point and state whether it is maximum or minimum. To do that, what you have to do is to consider the -1. There is a shift to the right, and what does the +16 do? Up 16. Okay, so if you shift right 1 unit, up 16, your vertex, which is your turning point, is 116. So when the parabola is written in this form, you get the turning point straight away. All right, so shift to the right, up 16. Okay. Now, would that be a maximum or minimum turning point? How do we know? Maximum. Why is it maximum? Because it's concave down, right? When you see the -4, it means concave down. So we say this is a maximum turning point. Yeah, see, can you see when I draw a concave down parabola, the vertex is the highest point. When you draw a concave up parabola, the vertex will be the lowest point. Okay, all right, let's rub this off. All right, okay, continuing. Let's determine the y-intercept. How do you determine the y-intercept? That's when x is 0. Let's substitute 0 into x. -4, 0 minus 1 square plus 16. And using your calculator, or you don't have to use a calculator because this is -1 square is 1. 1 times -4 is -4. Plus 16 is 12. Okay, so, or you can just use your calculator. Let me try to do it with the calculator. So you will do -4, open bracket, 0 minus 1, close bracket, square, plus 16. You will get 12, as expected. That's your y-intercept. And then we'll have to find the x-intercept. How do you find x-intercept? That's when y is 0. So you have to solve a quadratic equation. Now, how do we solve this? We have to find x. Now, how do we find x? Do we expand? You can expand, but it will take much longer. A faster way is to, when it's a perfect square form, just move the whole thing to the other side. So the -4 become +4. Okay, after you moved, you divide by 4. So you end up getting x minus 1 square equal to 4. And when it is in the perfect square form, you can just square root to find your answer. Okay, you can just square root. So let's square root that. X minus 1 equal plus or minus square root of 4. Okay. Now what's square root of 4? Is 2, isn't it? So you write x minus 1 equal to +2 or x minus 1 equal to -2. Can you see that? Square root of 4 is 2 or -2. So now you have to find x. So x equals to 3 or x equal to -1. These are the two x-intercepts. All right, that's done. So after we do this, we continue. Okay, so how to find y-intercept, how to find x-intercept, how to find the vertex. All right. Okay, now we're going to revise how to expand perfect square because this is important. Let's expand to see what pattern we get. All right, so let's enlarge this. Okay, let's look at this, revise. How to expand this. So hopefully I could write this here, a plus b all square. If you remember this formula, this is the perfect square formula. Okay, we learned that before in chapter 8, and you should know this very well by now. So there's 2 of these, one with the plus, one with the minus. So now we're going to use the one on the top to do the first one. So you go x squared plus 2 times x times 3 plus 3 squared. And if you simplify it, you get x squared plus 6x plus 9. That's your expansion. Try the next one. Okay, have a try. Alright, try the next one. X squared minus, because this is minus, then write 2x times 4 plus 4 squared. So you get x squared minus 8x plus 16. Okay, now we did both of these. These are perfect square expansion. Now we're going to learn how to complete the square. What does completing square mean? Alright, let's go through this. Alright, now find the missing term in order for the following to be a perfect square. So let's see if you can find any connection between the 6 and the 9 and the 8 and the 16. What are the connection between them? Well, we see that the 9 comes from halving the 6, which is 6 over 2 before you square. Okay? And the same thing with the 16 is to halve the 8 first, which is 4, before you square. So now we know how to complete the square. So if that was 10, what should we have to add to make a perfect square? 25, because you have to halve the 10 before you square. Okay? Get the idea? Or you can just write 25. Alright, try the next one. 9. Yep. So you just go, that's half of 6 is 3. 3 squared. Now, you always add a positive, even regardless whether this is plus 10 or minus 6, you always do a plus. Okay, how about the next one? What do I? 6.25, or you can just go 5 over 2 squared. Like that, if it's odd. And the last one, you just go, that's 1, so therefore you go 1 over 2 squared. 0.25. Okay, alright, so you just have to add this. Any questions? Now we know how to complete the square. We now have to move on to sketching parabola using the completing square form. 2 more examples. Alright, hopefully you're finished. Let's move on. Okay, let's look at this question. We're going to sketch this by completing the square, giving the x-intercept in exact form. Alright, let's try to do this. So your first step to complete the square, this is what you do. You write x squared plus 6x. What you need to do is to leave a gap plus 15. We're going to write this completing square in a gap. Okay, that's your first step. Leave a gap there. Once you left the gap, remember what do you have to add to make it a perfect square? What do you have to add? 3 square, right? Or 9. Because you added a 3 square, you have to subtract the same amount. 3 square. Get the idea? You add 3 square, but you subtract 3 square at the same time, so they are balanced. Continue. Okay, now let's explain again. You add a 3 square, you minus a 3 square. It's like saying 10 plus 9, 10 is equal to 10 plus 9 minus 9. Is that still 10? Are these two equal? That's what we do. Yep. Because if you add something, you have to balance it. Otherwise, if you just add one, they're not equal. So if I write 10, is that equal to 10 plus 9? 10 equal. Alright, well, if it's, why do we do this? That's a good question. Let me show you why we do this. Alright, so now what you do is this. You're going to write that as a perfect square, x plus 3 square. So that's a perfect square. This part here becomes this. Does that make sense? And then the other part, now you can do 15 minus 9. What's 15 minus 9? So that's your perfect square. Does that make sense why we do this? We add something to keep a balance. So we complete the square so that y is in this form. I could now sketch it. Now how do we sketch it? So now we can see this is shift left, 3, 6 up. Let's draw it. And you have to show the x-intercept if there are any. Let's try to draw this. So we've got the x and y axis. Do we have enough space? I think we should. Let's try again. Alright, so we got this. So we got 3 to the left and then 6 up. That's your vertex. Minus 3, 6. That's your first step. Thank you. Alright, let's continue. X and Y. So we got your x-intercept. Now you got your vertex. And then what we need to do is find the y-intercept. To find the y-intercept, you substitute x equal to 0, which is equal to, into the original formula, or the one you found. You should give it the same thing, 15. Okay, let's put 15 there. And then you get the parabola, because you got your vertex. So this one doesn't have any x-intercept. It doesn't cross the x-axis. Alright, okay, so that's done. So you got the parabola, vertex C, by completing the square. So we can sketch any parabola by completing the square. Then we can get the vertex straight away. Then we can get the shape. Right, try the next one. Next one is a little bit harder. Have a try. Yep. Yeah, alright, 3/2 or 1.5. Okay. Let's try to do this. Okay. Next one, so we complete the square, use the same strategy. You're going to write x squared minus 3x, leave a gap, minus 1. So what you need to do is half the 3, which is 3/2, but I prefer you to write in fraction because it's important later on. Minus the same amount. Okay, that's your first step. Is to halve the coefficient of x and then square it and subtract by the same amount. Okay, good. So continuing on, you'll get x squared by x minus the 3/2 that you found earlier. And then you have to do the rest on your calculator. Do -1 minus bracket fraction 3/2 square. What do you get? -13/4. Like that. Or if you want in decimal, it's okay. If you can write x minus 1.5 square minus, is that 3.25? Is that what it is? 3.25. Okay, so now we know what you do is shift up or right 1.5 but down 3.25. Okay, so let's try to draw this. So right 1.5, but we prefer to work with fraction. So where possible, if you can write 3/2 and then the other one down 13/4. Right, so that's your vertex. Prefer to write in fraction. It's better this way. Okay, so that's your vertex. And then what we need to do is to find both the x and y intercept. Let's find the x and y intercept. Starting with the y-intercept, which is much easier to find. X equal to 0. Y equals to 0 minus 3 minus 1. Y-intercept is -1. Okay, so somewhere here. Okay, -1. And then what we need to find is the x-intercept. And to find x-intercept, you put y equal to 0, but use this form, x minus 3/2 square minus 13 over 4. Okay, so we're going to solve this equation. Now run out of room. Let's find the x-intercept. So you move this term to the right, to the left. So write 13 over 4 equals to x minus 3 over 2 squared. Like that. And then you square root both sides. When you square root, be careful. Put plus or minus square root of 13 over 2. Because you square root the 4, becomes 2. And then you're going to move this term to the left. So you get x equal to positive 3 plus or minus root 13 over 2. Okay? So you get two roots. One of them is plus 3 plus root 13 over 2. The other one is 3 minus root 13 over 2. Minus 3 minus root 13 over 2. Let me fix this. Alright, now we are ready to draw. Let's try to draw it. So things get a bit tricky when there's a surd. So we'll pass through these 4 points. Oops. Okay. Alright, that's drawn. Make sure you show your x-intercept, the vertex, and the y-intercept on the graph. Alright, so that's called sketching by completing the square. Sketching by completing the square. Yep. Alright, any questions? So it can get a bit hard, so make sure you try all the questions today from exercise 9D.